Okay, moving right along, slope-intercept form. There's lots to do with this slope-intercept form. Number one, once you put it in this form, you can visualize almost what the graph will look like, and that's really what we're after. We want to see what the graph looks like for all of these variable equations and so forth. So the slope-intercept form is y equals mx plus b, where the slope is the m value, goes in here, and the y-intercept, that's the b. The y-intercept on the graph is where it crosses the y-axis. And we can see, looking at this graph, that it crosses at 1, 2, 3, 4, plus 4, okay? And that point's location is, the x value is 0, and the y value is 4. So I can locate that point. And so we know that m equals delta y over delta x. I can look at this, and I can say, well, my delta y, I can just count it. Graphical solution. 1, 2, 3, 4. So delta y is 4, and delta x is 1, 2, is a minus 2. So I'm just going to use the absolute value of that for the time being. So it's going to be 4 over 2, and that equals 2. So my slope is 2, and I can see that it's a positive. The next step would be to take and make the equation. Y equals mx plus b. I'm going to plug in the 2 that I just calculated, and I'm going to look and see what my y-intercept is, and I can make an equation. So now I can find out a value on this function, on this line. If I extend it way out here, I can just plug in the value of x that I want, and I'll get the y value. That's the whole idea of this. This is like a trend line with just 2 points. It happens to be perfect. And so now I have my slope-intercept form, and one thing I want to introduce, I don't think it's in the book, but we're spending so much time finding the y-intercept, we should spend a little time finding the x-intercept, because further on we're going to be making tables of x values, and we might make 10 or 15 values of x and have to plot each point, but you really only need to plot 2 points to get a perfect linear equation. And those 2 points, in my mind, would be the x-intercept and the y-intercept. They're the easiest to find. When we say that b is the y-intercept, we're actually letting x equals 0 and then solving for y. So when x equals 0, all I'm left with is b. So it's just a coincidence. I'm going to do a similar thing to find my x-intercept. I'm going to let y equal 0. So to find my y-intercept, I let x equal 0. Now I want to find the x-intercept, so I'm going to let y equal 0. So now I can just say 0 equals 2x plus 4, and I want to solve for x, so I got to subtract the 4 from this side and then divide by 2. I'm actually going to get a minus 4 over 2 equals x, and you can see that that's a minus 2. So x-intercept is a minus 2. I go up here and I look over, 1, 2, there it is, perfect. Sometimes, you know, it just happens that I'm using even numbers, so it looks good. So this is a good exercise to do, and I'm going to start having you solve. Whenever you solve for the y-intercept, you're going to find the x-intercept too. It's a good exercise. Okay, so that's the end of this exercise, and we're going to move on to more equations in the next video. Thank you very much.